Good evening guys, Vez here, and tonight we're going to discuss about my latest video that I posted a couple days or weeks ago where my printer was going crazy, stupid fast. Let's admit it, it was stupid, but a lot of people wanted to know how I was able to reach that stupid speed of 3000 millimeters per second, and I could even go higher than 3000, but let's say 3000 millimeters per second. So people wanted to know my recipe, how I was able to reach that speed. So in this one, I'm going to show you my recipe of being stupid and how I was able to do that with the VZ235. So let's jump right into it.
Login accepted.
Alright, before we jump into the recipe, I would just like to take a couple seconds to welcome you to my new office/studio/print room. This is the same room as you were seeing in my previous video, except now I had to move my entire office equipment here because I had to give my office room to my little son, little boy. He needs more space and we have some projects in the house. So I had to move my stuff here. So you know what? I'm kind of okay with that because I like that room already. This is the same desk as you were seeing before with my pegboard. All my tools are there, but I added this section here. So now it's a L-shaped desk, and I have my computer, my beefy computer right there. So everything will be better in terms of work process since my PCs, everything will be in the same room as my printer, my cameras, and everything. So I'm okay with that. If for my son, I would do anything. So that's just the way it is. So anyway, number one on the recipe, everybody knows about it, but it is speed. You want to go fast, you need to be light. There's no secret with that. You have to keep everything light. So on the VZ butts, 235 or 330, we try to keep everything light on the gantry. Every moving parts, we try to keep them light without sacrificing too much of stiffness. And we do that using aluminum parts, which is light if it's made properly, and it's stiff. So we're trying to keep everything stiff and light. As you stay light, you can go with higher acceleration, you can go with higher speed, and that's just the way it is. So keep it light is number one rule if you want to achieve higher speed. Number two, power. Obviously, we need power to move things around. So in the VZ butt, we have 4 stepper motors in a quad XY configuration, or how we call it, all-wheel drive. So we have 4 motors, which gives us a lot of torque, a lot of power, and that helps to move things around. But not only that, it helps on the resonance of the entire printer in a way that it will kind of divide the belt stretch or the belt mounting by 2. So you have a motor in each corner, so the entire length between what moves the belt is divided by 2. So we get crazy good input shaper result. We got good recommended acceleration because of that. So number 2 is power, motors, and we're using stepper motors, and the reason why we don't go with, at least the reason why I don't go with servo motors, because servo motors, of course, they can go crazy speed, they can go crazy acceleration, but they are, 1, a lot more expensive, 2, way harder to tune. It's not as simple or as plug and play as stepper motors, like the 3D printers we have here. So, and the last reason is I want to keep this printer running the same configuration that what we sell as a kit. So what you can see here in my videos is what you can buy and build, and I want to keep that same config as everyone else runs because it helps me to, you know, troubleshoot with people, help with people, and keep the same printer as everybody else runs, so it makes everything a lot more simple. So we stay with steppers, and we're using the new Super Power from LDOs, and they are kind of crazy. They can run all the way up to, well, I run them at 2.4 amp for this 3000 millimeters per second, but they are rated at a peak of 2.8 amp. So 2.8 amp, I would say it's safe to run them all the way up to 2.2, 2.3 maybe. Don't go higher than that unless you know what you're doing and you keep an eye on temperature. So power is number 2 on the list. Number 3, we are still under the power topic, but it's how we deliver power to those motors. On the VZ-Buts, we use external 5160, TMC external 5160 drivers. And the reason why is because they are just better than step sticks. They have more power delivery or better power delivery. They can take all the way up to 5 or 6 amp of power. They have way bigger capacitors that stores energy ready to deliver power to the motors. And they also run on a external gate at 12 volts. Compared to those, most of the step sticks that I've tried, they all are 5 volt internal gates. And what that means is at 5 volts on the gate, it will overheat if you try to go higher than maybe 2 amps. You're gonna have to cool them very, very high, but they still gonna lose a lot of power in heat. So the efficiency of those drivers is not as good as the external drivers from Mellow, the 5160. They are just simply very, very good. And at 12 volt gate, it's just gonna heat less, a lot less. So you're not gonna lose as much power in heat. It's gonna go all to your motors, and it's just gonna go better. They're just better. I've compared them with step sticks. I didn't test all the brands out there. I've tested, well, I'm not going to name brands because I don't want to say that here, but I've tested a couple brands and I couldn't reach those speeds and acceleration with step sticks. There are other options that you could go with, like NX Engineering. They have the Supernova, I think is the name of their product, where it's an off board that you install your step sticks on it, and they have bigger capacitors, but you're still with step sticks. I didn't test that option, but apparently you can deliver more power like that because of bigger capacitors. But for me, the 5160 external from Mellow, they're just way better than all the step sticks that I've tested. Just way better. So I would highly recommend those if you want to go with higher speed. And they can take 48 volts. You can take like a champ. They can even take more voltage if you like, but I currently stay at 48 volts for all I do, and it's just perfect. It's enough power. Number 5 on the list, keep the motors cool. Water cooling. Water cooling is how I was able to push those motors way higher. I'm able to crank more current to the motors without them overheating. And I'm running 2.4 amps right now on the motors, and they stay cool. This is very awesome setup. I've upgraded the tubings. I've upgraded the radiator in the back. It keeps the motor cool. And the reason why I did that is because I couldn't do all those tests. I had to stop before each run. I could just run maybe 1, 2, 3 tests, and then boom, they would lose all their powers. I had to let cool down the printer and start over again. With water cooling, I can go pedal to metal, and the motors will not start losing power because they overheat. So it's just way better. Can you do it without water cooling? Yes, you could do it. Except you're not going to be able to do it over and over and over and keep pushing like that. But it's not really a big deal because we don't print at 3000 millimeters per second. This is just for testing purposes. And it's stupid again. So is it mandatory? No. Is it cool to have water cooling? Yes, I think. I personally like it. I've upgraded everything. It looks good. I like it. What can you do? It's just cool. Water cooling. Number 6, still in the same power topic, is power supply. You need a very good 48 volts power supply. You don't want to do this at 24 volts. It's simply not enough. 48 volts is really where the motors will start shining. And the reason why is at higher speed, the more a stepper motors will spin, it will generate what we call a back EMF. And what is that is a motor, when it spins, it will start to generate a certain voltage, and that voltage will combat the input voltage. So it will kind of fight its own power like that, and the more voltage you give it, the more you can fight back EMF. So in theory, it gives you more top speed going like that with power supply. On this one, I'm using a 600 watt power supply, which is overkill, but after discussing with my buddy Eddie, the engineer, he told me that on his setup, running the speedy power motors at, I can't remember the current, but at high current and at super high speed, he monitored and he was reaching almost 90 watts per motor. So he told me I would probably be around 100 watt, even more, per stepper motors at that speed and that current, which is kind of crazy. So 400 watts just for motors. So I'm okay. I have a 600 watt power supply. So that was number 6. Power supply, 48 volts. Number 7. Those TMC drivers, you need to tune them. And I'm not the pro here. I got to give all credits to my buddy Eddie, the engineer. And I think we've discussed, and I think he's going to make a video on how to tune them. Maybe, maybe not. It's a lot of work, but it was discussed with him that he's going to try to do it. So all credits goes to him because I'm not a pro there. I know what I'm doing, but I'm not as good as this guy. And he has the tools, a oscilloscope, whatever the pronunciation, that machine where you can monitor the current on a monitor, a oscilloscope. So he did that for me, and I got a couple settings that I've used for the TMC drivers. I'm going to put them down in the description down below, so feel free to use them, try them. For me, this is really what unlocked the power and made the motors run more quiet and smoother. But that one last setting I was missing was that TPFD, setting that to 0, and it kind of turned off the fast decay. And what that thing does on the stepper, when you look at the oscilloscope without that setting, the stepper drivers was kind of actively braking active braking, if you know what active braking is in a motor. But anyway, it was kind of generating some current to brake the motor, slow down the motor between phases, if that's the right word. I may not be explaining it, but I'm going to put a photo right here. You're going to see it with and without. And as soon as I've entered that setting, boom, I was able to go higher than 3,000 millimeters per second. But not only that, I was stuck before at around 2,900 something, but I couldn't go higher than, like, if I remember, around 40K. But with that setting, I could go all the way up to 80K at 3,000, and it was working. 80K, 3,000 millimeters per second, crazy stuff. So yeah, I'm also going to put a link in the description about a TMC spreadsheet. It's a calculator that you could use to help you tune the drivers. And I'm not going to tell you how to use that. I don't really understand all I'm doing in there. I'm going to leave that to my buddy Eddie, the engineer. I think he's about to make a video on how you would tune with a oscilloscope, at least how to understand what's going behind the scene and what's happening between the drivers and the motor. So that will be a very, very, very interesting video. So if you have not subscribed to his channel, I'll put a link in the description as well. Eddie the engineer, he has some very, very interesting stuff. If you like science like me, he's the man, very, very smart man. So thank you, Eddie, for helping me reaching those speeds. All the credits goes to you. And now I can go crazy fast. So look in the description, everything will be there. That was number 7, tuning those stepper drivers. Number 8, believe it or not, but it's going to be your 3D printer motherboard, or the electronics, or what we call the MCU. This is what drives the motors. This is what tells the motor to move that amount of steps in that direction. So it's done by step pulse. It's a electronic signal that is sent to your stepper drivers, will be translated to your motors with that. So you need a really fast processor in order to achieve very, very high or very, very fast step pulse. What I refer by step pulse is the number of steps per second that a motherboard can deliver to your steppers. So in a printer with 4 steppers, it could be servo motors, it wouldn't matter because we're still going to use step to do the movement on the printer. So whether or not servos, steppers, still the same, you need very high processing power. So we're using 1.8 degree steppers, so there will be 200 full mechanical steps in a full turn of a motor, and we're using a 20T Polite with the GT2 belt, which means a full turn of a motor will give us 40 millimeters of travel. So if we do the math, we end up with 5 full mechanical steps of a motor to do a millimeter of travel. So we have 4 motors, so multiply that 5 by 4 motors, we end up with 20 full steps that the 3D printer board has to generate to do 1 full millimeter of travel. So now we need to multiply that by 3,000 because we're going to go 3,000 millimeters per second. So we end up with 60,000 full steps of a motor per second, which is a lot. But then comes in the micro stepping. So micro stepping will divide each mechanical step into subdivisions. So if you're using 16 micro steps, we need to multiply that 60,000 by 16 micro step, and we end up close to 1 million step pulse per second, which is crazy. Well, the real number is 960,000 millimeters per second, very close to 1 million. So you really need a very fast processor, or at least something that can generate step command as fast as close to 1 million. And in my case, on this printer, on the VZ235, I'm using a Super 8, but it's the standard version, which is the CPU at, I think it's 168 megahertz. And to reach 3000, I had to lower down the micro stepping to 8 micro steps. So otherwise it wouldn't be able to do it. I was shutting down clippers because the MCU couldn't follow the demand. It was just asking too much, and it was not processing power like CPU power, but I think, and I'm not too sure here, I'm not the expert in electronics, but I think it's just a matter of a frequency and how much step pulse that the electronics can generate in a second. So I had to lower it down, but I know on this printer, the 330, it uses the Super 8 Pro version, which the CPU runs at 525 megahertz or 550, I can't remember, but anyway, Clipper caps it at 400 megahertz, but that's still about 3 to 4 times higher than the standard version, and this one is capable with that. So you need fast electronics and very good processing power. This one is using a Raspberry Pi 4, this one is using a Raspberry Pi 3, and I get higher with the Raspberry Pi 3. So it's not the Raspberry Pi that is not following, it's really your 3D printer board. So you really need high performance 3D printer board in order to achieve that speed. So that was number 8. Number 9. Number 9 is going to be linear rails, and this is going to be a little bit controversial here. Some people will agree, some will disagree, but I'm going to tell you my recipe again here. So linear rails, if you want to go fast, you need the least amount of frictions, and if you are using high wind rails or whatever the rails you're using, MGN rails, and you're using high preload, this is going to suffer for speed. Also, if you're using a very thick grease instead of using oil, that's going to slow you down. It's going to add friction. It's going to be harder for the motor to move your tool head. In my case, I'm using high wind with Z0 preload, which is no preload or very light preload. I can't remember exactly, but I'm not using Z1 on this one, and it's working good. It's very stiff. I got very, very good input shaper results, but it's moving freely, and that's really important. So personally I use this kind of oil to lubricate my linear rails, and it's a Super Lube PTFE base. And I know, don't shoot me just now, a lot of people will say don't use PTFE on a linear rail. I do. I've been using this kind of stuff for the past 2-3 years, and it's still going good. This is still the same rail that I've installed on day one, and it's been beated to death, and it's still going strong, and I don't see any sign of wear, so it's still going good. I know people will tell you PTFE will be bad because of the microparticles that will have the rail. It's going to damage your rail eventually, and also it's not good enough because instead of rolling, the bearings will slide. But I don't know, I've had good result with that, and I'm going to keep using that. I don't care if I need to replace my rails after a couple years. That's just fine with me. It's the price to pay to go crazy stupid like that. So linear rails, the least amount of friction as possible. That's going to be your number 9. And maybe there are better oil to use than PTFE oil. I just use this one because it has this little syringe type that I can directly feed my linear rails directly in the little hole there to grease or to oil the rail. And for me, it's been good like that. So that was number 9. And the last thing, number 10, you're gonna need cojones. I don't know if I pronounce it right, but that means balls. And whether you're a girl or a guy, you're gonna need courage. I'm telling you, at that speed, it gets really, really scary when you go at 3,000 millimeters per second. It's fast, it accelerates fast, and if you crash, if you miss something, it's gonna crash hard, and it will probably break your printer. It will break apart whatever is the print head or whatever it hits. It's gonna hit it very hard, so you may damage your printer. So consider yourself warned. If you do this, I suggest that you do little increments in terms of speed and acceleration until you find your breaking point. And don't send a G-code that contains multiple lines of movement at that speed, because the motors will fail, but Clipper will still try to do those commands, and it will end up crashing everywhere. So be careful. Do only when you are sure that it's going to be able to do it, and at all time protect your printer. Keep your fingers ready on the emergency button or the power switch or power cord. Be ready to shut down the printer as soon as you see an issue with that. But again, don't do this. It's useless. So that was number 10. Or you might need a little bit of rum. I use a bit of rum in order to do that. Could be beer, could be wine, could be anything that's gonna calm you down, because your heart rate will pump up. I'm telling you, it's scary to a point where, yeah, your heart rate is coming up. So that was number 10, and that ends it. You get all my recipe of going stupid at 3,000 millimeters per second, but don't do it. All right, that was it for this video. I hope you guys enjoyed it. Maybe you learned something new, maybe not. If you liked it, please smash that like button. Subscribe if you have not, because we're gonna come with more content. I know I was a bit busy recently. I didn't do a lot of YouTube, but that's gonna change because I like doing this. I like my new place. I like how it looks. I'm very happy with that. So I'm gonna do more video. I'm gonna have fun with you guys because I love being with you all on this. Take care. Thanks again for watching, and see you on the next one. Goodbye.